Morning guys. Today we're going to look at the next part on the normal distribution stuff. All right. So what we looked at the other day, if we just do a quick review of the first section, so we talked about the z-score. The z-score is the number of standard deviations away from the mean. All right? And our traditional thing is we have our mean at 0, and we will go 1 standard deviation, so we have a z-score of 1. Go 2 standard deviations as a z-score of 2, and so on and so on. And if we go this way, it becomes -1, -2, and so on. Now, the key thing is, when you start looking at this particular diagram, if we start shading this area in here, right, so we said that is actually 68.24 or something like that. Doesn't really matter, but it's about 68% of the population lies in there. Well, that is the likelihood of someone getting a value between, say, -1 and 1. It's an area, okay? So what we're looking at that is an area under a curve. So all the possibilities account for 100% of the area, or, you know, so it gives you a really simple way of thinking about the probability of something. All right, so probability is 100% of all the outcomes, and it's an area, so it might be, you know, represented here by 0.68. All right, so anyway, when we start looking at the other examples, I think it will become quite clear what we're talking about here. All right, so what we went through the other day is we went through and we looked at some examples where you will use the normal PDF and the normal CDF. Right, so we've got the lower value, our mean value. Now this is actually the sample mean symbol, and that's our sample mean standard deviation. All right, so and then we do the normal CDF where we actually have a lower value and an upper value. All right, so we went through these examples of greater than 25, between 25 and 26, all right, less than 25. So the key thing there was, when we were looking at it, right, if we don't have an upper value, we make it e to the 99. If we don't have a lower value, we make it e to the minus e to the 99. All right, so, and if we want to look at exactly getting that particular value, then we use our PDF. All right, so they're all the examples, most of the variations that you'll get for the normal CDF. All right. Coming down to this one here, this is a slightly different question, right? So if we just read it, the average score in a physics test was found to be 46, and a standard deviation of 25. Assuming that the scores are normally distributed, the teacher decides to award an A to the top 7% of the students in the class. What is the lowest score for a student to obtain an A grade? Alright, so what we should do, the first thing we should do is we should always write down, alright, we should always write down what our mean is. Now that's the symbol for our population mean, and that's the symbol for our population standard deviation. Alright, so you need to be aware of that. Now the top 7% over here of our particular sample, alright, is 0.07. Right, in terms of the area, so it's this area up here. So that means that there is 93% on the lower side, isn't it? So when we going, and so obviously we'll need to look at that. So that's going to be 0.93. Now the thing about the inverse norm, when we start thinking about doing this, the inverse norm always works from that side going this way. Alright, so if you've got an upper value, you always need to make sure that you think of the complementary area. Alright, so you have to have the complementary area for that. So what we have to do is have to do our inverse norm. I'll show the calculations on the calculator. Alright, just clear that. So again, it's the standard deviation thing over here. So we go inverse norm, the distribution. So inverse norm is the third one there. And so what you'll do is you'll put in the area 0.93, because that's the area that we're looking at. Our mean score is 46 I think, and our standard deviation was in fact 25. Right, and then paste it in, and then you get that answer of 82.89. So when we go back to writing it down, what we need to consider is 82.89. So obviously you have to get an 82, right, to get an A. All right. So I think those questions are quite simple. Right. So working your way backwards, I think it's a really good way of doing it. Just another little variation of the normal distribution stuff. This is essentially the same sort of question, so I won't go through this in great detail, but the first part of that is when we start looking at x being greater than 50. Right, so again we don't have an upper value, so we use our e to the 99, and we use our 50 as our lower value. And this is the interesting thing, our variance, it tells you what your variance is. And so our standard deviation is the square root of the variance, which is 11, the square root of 11. So you just put that into your calculator like that, in terms of, straight into your calculator like that. So when we do that calculation, we go into our normal distribution number 2, right? So our lower value was 50, our upper value is e to the 99. Our mean value is 41, and our variance is the square root of 11. Right, so square root of 11. So you put it straight in there like that to the calculator, and then you can get your answer of 0.03327. All right, so pretty easy sort of question to do. A little variation, the next one's pretty standard, where you've got between two values. And then the last one, right, so in the sample of 200 cod, how many would you expect to be at least 45 centimetres? All right, so what it requires you to do is go through the process of what we just did then, right, work out the likelihood or the percentage of cod that are going to be greater than 45. So the easiest way to do that in your calculator is second function enter. Right, it's the same calculation as the last one really. Go and change that to be 45. Enter. Right, so it gives you that value that we've got written down here, and then that value has to be times by 200. Right, if we times that by 200, that will tell us the number of fish that or number of cod that we would expect. So you can't have obviously a part of a fish. You've got to have a whole fish. So you have to round that down to 22 fish. All right. So that's a slight variance on what we've been doing with the other one. Now, I want to go through this example. This example is actually a little bit tricky, but once you get the idea of what you've got to do, I think it's quite straightforward. So to find the mean and standard deviation of normally distributed random variable x, we're given some information. We're given that when x is greater than 80, it counts for 0.1 or 10%. And the probability that x is less than 30 is in fact equal to 0.15. So what we're looking at there is the 81, so the score of 80 being greater than 80, 10% of your sample lies there. So therefore what we've got here is we've got 90% of our sample lying down this side. Okay, so what we really need to do is we really need to find our z-score, and I'll show you how to do that in a second. Alright, so over here we've got 0.15, so we know that 15% of our values lie less than 30. So that means I don't need to work out what the other bit is because I'm working left to right, so I should be happy with that. Now, to get your z-score, remember our z-score is based on a mean of 0 and a standard deviation of 1. Alright, so all I need to know is I need to put that value, that area in there. So again, I go back to my calculator, I go to my inverse norm. Alright, so that's number 3. And for the top one, I'll go 0.9. That's my area. I've got a mean of 0 and I've got a standard deviation of 1. And that will tell me what my z-score is. Right, my z-score is 1.286. Okay, so that's that one. If I do the same thing for the other example, Come down to number 3 again. Right, now my area is 0.15. No, not 0.5, 0.15. Enter. And then I come down to that and I paste that. And that gives me a z-score of negative 1.03. So it's just over 1 standard deviation away from the mean to be that, all right, for the sample. So that is really useful to have these two scores, all right. So I've got this score here, which is my z-score, all right, for the upper, and that's my z-score for the lower. Now, keeping in mind, we do have a formula for working out the z-score. All right, the z-score is in fact the value, take your mean over your standard deviation, and that's equal to whatever your z-score is. All right, we haven't done a lot of the questions like they do in the textbook because our calculator does this for us. But this is the example where you will need to use your z-score. All right, so we're making those two things equal, and we'll do the same thing over here. 30, take our mean value of whatever, over our standard deviation is equal to negative 1.0364. Now, what I can do is I can bring this value and times it up to the top. And I'll do the same thing over here, right? And I can do that there. Now the next thing I can do, if I want to do this by hand, I can bring the 30 across. So I bring the mean across and I bring that across over there. And that will give me the expression of the mean's equal to 30 plus da da da. Right? Now at this stage here, if I wanted to, I could also bring the mean across. I could have written this as 80 equals the mean plus 1.2816. I could have done that, and I also could have done the same thing over there. I could have said 30 is equal to the mean plus that. This would have been in the form of x plus y equals some number. Right, and you can put those two equations into your calculator and do the simultaneous equation solver. Right, but we haven't chosen to do it in this particular case. So then what I've done is I've substituted this value into this equation here. Right, so substituted this value into this equation, and that is what we're seeing here. All right, so we're seeing that being put in there. So in other words, when I do that, 50 take 30, and that will be minus, so when I bring that across, it will become plus. So then we get an expression which is 50 is equal to 2.318 times by the standard deviation. So our standard deviation is going to be equal to 50 divided by 2.318. This is just a bit of algebra that you've got to do. That gives me an answer of 21.857. Then I have to do is I have to substitute that value back into this equation up there. Alright, so if I substitute that back into that equation, I get my mean value of 52.36. Alright, so this is probably the third style of question that you're going to get with the normal distribution stuff. So the first question, or the first type of question, you'll either need to use your normal PDF, CDF, right, and you've been given your mean and been given your standard deviation, and just do that on the calculator. The second type of question is the one where we did with the test scores. Okay, so that was this one where you get given that here's the mean, here's the standard deviation. We want to look at the top 10% or 7%, or we want to look at the bottom, 10%, 20%. All right, so you can put any percent in there. And so therefore we're using our inverse norm here to actually work out what our value might be. And then the third style is we don't have our mean or standard deviation, and we need to use our z-score, right, our z-score here, to actually work out what it is. Alright, so I hope that helps you finishing off those questions in the exercise to do with normal distributions. I think it's pretty straightforward, and really once you get the idea of what's going on, I think you'll find it really easy. So good luck with those, and make sure you catch me if you need some help.